Hello everyone, welcome back to another video on the Education Always channel. Today we'll be looking at approximation. In this video we will cover estimating calculations, limits of accuracy, upper and lower bounds, and applying and interpreting upper and lower bounds. Estimating calculations. Sometimes it is a good idea to estimate the value of a calculation rather than work it out exactly. In this situation, round the numbers in the question before performing the calculation. Usually the numbers are rounded to one significant figure. The approximately equal to sign is used to show that values have been rounded. For example, estimate the value of 23 times 67. Rounding to one significant figure gives 20 times 70. This is 1,400. Therefore, 23 times 67 is approximately 1,400. There is another example on the screen for division. Now, limits of accuracy. If a number or measurement has been rounded, it can be important to consider what possible values the exact value could have been. For example, if a kitchen unit is 600 mm wide to the nearest 10 mm, it could actually be any width from 595 mm up to 605 mm, so it might not fit into a gap that is exactly 600 mm wide. To describe all the possible values that a rounded number could be, we use limits of accuracy. The lower limit is the smallest value that would round up to the estimated value. The upper limit is the smallest value that would round up to the next estimated value. For example, a mass of 70 kilograms rounded to the nearest 10 kilograms has a lower limit of 65 kilograms. Because 65 kilograms is the smallest mass that rounds up to 70 kilograms to the nearest 10 kilograms. The upper limit is 75 kilograms, because 75 kg is the smallest mass that would round up to 80 kg. This can be shown as an error interval, which is the difference between the highest value and the lowest value, using equality symbols. When more than one value in a calculation has been rounded, the upper or lower bounds for each value should be used in the calculation to find the greatest or least possible values that the calculation can take. On the screen are the rules for using upper and lower bounds. If a value is rounded, its upper or lower bound as appropriate should be used when finding the largest or smallest possible answers to a calculation. For example, a bag of flour has a mass of 1,500 grams to the nearest 10 grams. Find the upper bound for the mass of 10 bags of flour. The upper bound of 1,500 grams rounded to the nearest 10 grams is 1,505 grams. The upper bound for 10 bags of flour is therefore 10 times 1,505, which gives you 15,050 grams. Another example. Jack is 1.8 meters tall, rounded to the nearest 10 centimeters. Ella is 1.63 meters tall, rounded to the nearest centimeter. What is the smallest possible difference in their heights? To find the smallest difference, we need to use the lower bound for Jack's height and the upper bound for Ella's height. The lower bound of 1.8 meters rounded to the nearest 10 centimeters is 1.75. The upper bound of 1.63 meters rounded to the nearest centimeter is 1.635 meters. The smallest possible difference in Jack and Ella's height is 1.75 meters minus 1.635 meters, which gives you 0.115 meters, which is 11.5 centimeters. And that's it for today. Thank you everybody so much for watching. Please don't forget to pop your questions down in the comments and like and subscribe for more. Thank you. Bye.